All right, folks, let's dive into an example. Example 1, graph the quadratic function f of x is equal to 4x squared minus 8x minus 3. Find and label the domain, the range, the y-intercept, the axis of symmetry, the maximum and minimum values, the x-intercepts, and I should have said in here, the vertex should be in here somewhere. And it should be in black, not red. Okay, so let's dive right in. A couple of things that we can answer right away, at least one thing. So the standard, stop it. The standard form is f of x equals 4x squared minus 8x minus 3, where a is equal to 4, b is equal to negative 8, and c is equal to negative 3. So right away, I can tell you that the y-intercept is 0, negative 3 because of this c value. Boom, nailed it. What else can we tell you right away? The a value is positive. Well, while that doesn't tell me anything directly, whoops. Since the a value is positive, I know that this is going to be a minimum because the parabola is going to open upward, which means that whatever the vertex is at, it's going to have a minimum. So it's going to have a minimum value. I don't know what that is yet. So let's go find out. From this information, we can then say that h is negative b over 2a, which is negative 8 over 2 times 4, which is 1. And then that tells me that the k value, which is f of 1, is 4 times 1 minus 8 times 1 minus 3, which is negative 7. So the vertex is 1, negative 7. Now, without graphing a lot of this, I can pretty much answer a lot of the rest of this here. So now that I know what my vertex is, and I know that it's a minimum, I can now tell you it has a minimum value of negative 7 at x equals 1. And the axis of symmetry is the x equals h value, which is x equals 1. And once I have that, I can tell you the domain. Well, I told you the domain right away. The domain is always all real numbers for parabolas. Always. So that's kind of a freebie. The range, though, because this parabola opens upward and it goes as low as a value of negative 7, the range has to go as low as negative 7 and up to infinity. So we're really getting a lot from the vertex right there. And then what's left? The only thing that's left is the x-intercepts. And I guess we can just use quadratic formula for that. Let's just do that. X is equal to negative 8 plus or minus the square root of negative 8 quantity squared minus 4 times 4 times negative 3 all over 2 times 4, which is 8 plus or minus the square root of 64 plus 48 all over 8, and this becomes 8 plus or minus, that was 112, we already did that one, that one's 4 root 7 over 8, and this is 1 plus or minus root 7 over 2. So the x-intercepts are 1 plus root 7 over 2, comma 0, and 1 minus root 7 over 2, comma 0. And now finally we can begin to graph this sucker. So let's graph it. I know that the vertex is going to be at 1, -7, so I'm going to put my x-axis up kind of high here so that I can go down low. 1, 1, 2, 3, 4, 5, 6, 7. There's my vertex at 1, -7. It's also my minimum because I know that the parabola opens upward from the a value. The y-intercept is -3. So let's see, 1, 2, -3, 0, -3. That's the y-intercept. I'm going to put my axis of symmetry in here now. That's usually a good time to get it in. That is our AOS, and it is x equals 1. Because of the axis of symmetry, I get this other point for free. It is the mirror image. That one is at 2, -3. And I can begin to draw this parabola. Looks something like that. Well, that could have been better. Now, the range, which was -7 up to infinity, can be illustrated by the fact that this goes as low as -7, and then the graph goes all the way up to positive infinity. You didn't need to graph that, but that's the range, and I just wanted to illustrate that. Now, the only thing that we really have left to illustrate on here are the x-intercepts. And here they are, and you'll notice that they are on either side of x equals 1. That's kind of hard to read right there. Let's see. X equals 1. This is 1 plus a little bit to the right, and that is 1 minus a little bit to the left. Oops, comma 0 for the x-intercepts. And there it is. That's the graph of our parabola.